Page 47, 2.5, day 2, we're going to be graphing instead of solving rational equations. Okay, so please remember we need to factor completely. I am always going to denote that with the letter F. And then after that, we are going to find wholes. I'm always going to denote that with the letter H. After that, we are going to find the vertical asymptote and the horizontal asymptote together. So we go a little bit out of order here. And then after that, we are going to always determine the x and y intercepts. So everything's very straightforward here. You do have to memorize these steps. These are not going to be given to you. But here's one thing I'd like for you to remember. 5 and 6 are about asymptotes. And you're either going to have a horizontal asymptote, no asymptote, or an oblique asymptote. And you'll see how that's going to work as we start to work through some examples. But what I wanted to let you know is when you are looking at number 6, this is the only time you look at the original problem. Most of the time you look at the current line of work that you are working on. So sometimes some things are going to cancel out and what we are working with is going to look completely different than what we started with. But when we do the horizontal asymptote, we always look at the original printed problem on the paper. Okay, so let's go ahead and get started here. Since these are just a little bit out of order, I'm going to write these steps down. The first step is to always factor. The second step is to always find wholes. The third step is actually to find your vertical asymptote, then your horizontal asymptote, or it may be an oblique there. After that, we find the x-intercepts, then the y-intercepts, and then we're ready to graph. So this is always the order. It looks a little crazy, I know, but if you can remember it, it's just going to make these very seamless for you. You won't get hung up on anything. All right, let's go ahead and go through our little checklist here. Remember, the first thing we're going to do is we are going to factor. The top and the bottom are both factorable. The top, I'm going to slide and divide. So that's going to be a 4 and a 3. I got to go back and divide by what I slid. So the top is going to be, just kind of making sure you guys can see everything, 3x plus 4. And then the other one's x plus 1. This bottom, it factors. It's pretty easy. That's just going to be x plus 2, x plus 1. Okay, that's completely factored. Before we move forward, just remember all of these little factors are understood to have exponents of 1. If I counted up the top degrees, 1 plus 1 is 2, which is where I started. Bottom degrees, 1 plus 1 is 2. Everything's accounted for. So we have factored that correctly. The next thing that we're going to do is we're going to find the wholes. And wholes are factors that cancel out because they have the same exact thing on the top and the bottom, which, if you notice right here, you're going to have a whole because x plus 1 is both in the numerator and the denominator. So with my red pen, I always do discontinuities in red. Those actually cancel out. They're going to go away completely. Now, wholes are always points. They're jumps. Remember, jumps are always points. So we're going to take the opposite in the parentheses. So we're going to start our ordered pair for a whole with -1, but some kids think it's 0. It's never 0 right here. 99% of the time, you're not going to write a 0. The output, remember, we need an output for this input. You plug it into what is left over. So look, after those x plus 1s cancel out, we just have 3x plus 4 over x plus 2. And that's going to be it. To find the output, we're going to plug a -1 in right here. So this is going to be 3 times a -1 plus 4 over -1 plus 2. So our whole is going to be -3 plus 4, which is 1, over 1 minus 2, which is 1. So our whole has an ordered pair at 1, 1. So we're done with that. All right, let's go ahead and talk about the intercepts. for the intercepts, what you need to remember is the intercepts are going to find in just a moment. Let's talk about the vertical asymptotes. It's from the bottom. That almost looks like a down arrow to remind me vertical asymptotes come from the bottom. And it is just simply, what can x not equal? What do we have to block out here? We know x cannot equal a -2. Notice I'm not looking at this. You always look at your current line. X cannot equal -2. Now remember, this is understood to have an exponent of 1. Remember how this right here is understood to have an exponent of 1. 1 is odd. So when you have a vertical asymptote raised to an odd power, it is going to have opposite end behavior. And this is very, very important. We would get stuck sometimes if we forget to label our behavior. And that's going to make sense when I actually start putting this stuff on this grid. All right, so we're all about asymptotes. We found the horizontal asymptote. We found the vertical asymptote. Let's find the horizontal asymptote. Remember, the horizontal asymptote is the only time you look at the original problem. And horizontal asymptotes are like degree fights to me. It always reminds me of the numerator and the denominator, like fighting it out for the highest degree. If the highest degree in the numerator and the denominator, if there's not a highest degree, if they both equal, it is just y over the leading coefficient of the top divided by the leading coefficient of the bottom. If the highest degree is the denominator, if the denominator has the most degrees, so easy. It's just the x-axis, y equals 0. If the numerator has the highest degree, we don't even have a horizontal asymptote. What we're going to have here is an oblique asymptote, and that's when the numerator has the most degrees. And we'll talk about that later. What we're going to talk about right now is how they're both equal here. So 2 degrees on top, 2 degrees on bottom. It is the leading coefficient of the top, which is 3, divided by the leading coefficient of the bottom, which is 1. So the horizontal asymptote is just going to be y equals 3. Okay. So let's go ahead and determine the x-intercept. The x-intercept comes from the top, just like it would if it was a polynomial. It even has the same kind of behavior for polynomials. So the x-intercept is going to be this number up top. Remember, this is understood to be to the power of 1. So my x-intercept is going to be -4/3. Remember, it's always opposite. 0. And I'm going to put a little s right here to remind me it goes straight through from one side to the other, because remember, it had an exponent of 1. All right, let's go ahead and talk about the y-intercept. So for the y-intercept, we're just going to plug in zeros right here. 3x wipes out, so does the letter x. You're just left with 4 divided by 2. 4 divided by 2 is just 2. You have everything you need now to graph this. We're actually going to fill in these blanks later. Let's go ahead and graph based on what we did. So when you guys graph this, you also go in the exact order that you had wrote your steps. So let's go back to the top. Factoring, of course, doesn't go on a graph, but a whole does. Remember, we had a whole at -1, +1. So let's say the whole is right here at -1, +1. I always use red for wholes. Next, we had a vertical asymptote at x equals -2. So this is -1. We'll say -2 is right here. Look, I'm not writing -2 on the actual grid. What I'm going to do is I'm just going to label this asymptote as x equals -2, which is a requirement on tests and quizzes. Notice I drew the arrows also. Another requirement is to write the behavior right above where you wrote x -2, so write op for opposite behavior. Same here, write it down here. We don't want to risk any chance of forgetting that. All right, let's go ahead and graph our y equals 3, which is our horizontal asymptote. Remember, that was +1, so let's say +3 is like right up here. And again, I'm not going to write it on the actual axis because I'm just going to label my horizontal asymptote, y equals 3. All right, let's go ahead and plot this x-intercept. Negative 4/3 is going to be just barely after that negative 1 there. And remember, that is straight behavior. And then we have a y-intercept up there at the 2. Remember, this was positive 1, so this is going to be positive 2. Now, if I have blanks here to fill this in, I don't necessarily have to label the graph. I'm going to go back and fill in all my points after we connect what's going on here. So if you notice, I don't really have too much to go on, but I do know these 3 ordered pairs, they're going to connect for sure. But remember, we're going to hop over that hole. So obviously a graph was down here somewhere. It went straight through the other side. It's going to hop over the hole. It's going to cross the other ordered pair, which is the y-intercept. And then remember, from here, graphs hug these asymptotes. So now I'm going to swing around and get as close as I can to that horizontal asymptote without touching it. I'm going to get closer and closer and closer to this vertical asymptote over here without touching it. Now remember, I have an opposite behavior here. If you notice, I have one vertical asymptote. For every vertical asymptote, you always have to consider the other side. I reminded myself this was opposite. What's the opposite of a down arrow? An up arrow. Let me hop over to the other side, go to where the up arrow is, and now I know where the graph picks back up. Picks back up here because it's opposite behavior around just this line. So remember, graphs love asymptotes. As soon as they get towards another asymptote, they start getting closer and closer to the horizontal. So that's full credit for the graph. Let's go ahead and kind of review how we found some things here. All right, I already have my blank filled in for the hole. How did I get the hole? I crossed out the matching factors on top and bottom. I took the opposite of what was inside the parentheses and plugged it into the remainder to get the output. X-intercept. How did I get the x-intercept? Remember, the x-intercept is from the numerator. It is just like you setting this equal to 0 and solving. So the x-intercept, remember, is negative 4/3, 0. And it had a multiplicity of 1. So I know that it went straight through from one side to the other. Y-intercept. How did I get the y-intercept? Remember, the first value is 0. When we plug in a 0 on the top and bottom here, those wipe out completely. 4 divided by 2 is 2. Vertical asymptote, that comes from underneath. What can x not equal down here? It cannot equal a negative 2. So I have to block out my vertical asymptote at this line. Did my vertical asymptote have even or odd exponent? It had an odd exponent, which means I had opposite arrows on either side of it. Horizontal asymptote. How did I get my horizontal asymptote? Remember, it's a degree fight. Most of the degrees are not either in the numerator or the denominator. They were equal. So I took the top number, which is a 3, and divided it by the coefficient of 1. 3 divided by 1 is that. And remember, these are exclusive. You either have one or the other. So since I had a horizontal asymptote, there's none for oblique. And that's how you graph your rational expressions or your rational graphs.